In this video, we're going to look at solving a non-homogeneous second order differential equation where fx is in the form of k sine x. In our case, it's going to be k sine 3x. So we solve the auxiliary equation first. So we say it's m squared minus 5m plus 6 equals to 0. So that's going to be m minus 3 and minus 2 equals 0. And our roots are m equals 3 or m equals 2. So which implies that the complementary function is y equals a times e to the power 3x plus b times e to the power 2x. So if we notice in our table of particular integrals that we have on the right hand side, if our function is in the form of k sine x, in our case it's k sine 3x, our particular integral would look like this: y equals c cos x plus d sine x. In our case in particular, it will be y equals c cos 3x plus d sine 3x. So we're going to say, we assume that our particular integral will take the form y equals c cos 3x plus d sine 3x. So we're going to differentiate this. So we say dy by dx is going to be minus 3c sine 3x plus 3d cos 3x. And now we need to find the second derivative. So we're going to do that here. So we're going to say d2y by dx squared is going to be minus 9c cos 3x minus 9d sine 3x. Now we need to substitute this into our differential equation. I'm going to write each of these on a separate line for consistency and for clarity. So first we've got d2y by dx squared, so we're going to write that down here. So it's minus 9c, just write it down here, minus 9c cos 3x minus 9d sine 3x. Now in our differential equation we've got minus 5 times dy by dx. So I'm going to write that on the next line. Minus 5 times what we've got for dy by dx, which is minus 3c sine 3x plus 3d cos 3x. And then what we have here, we've got plus 6y, so it's going to be plus 6 times whatever the particular integral was, so it's plus 6, and our particular integral in question is c cos 3x plus d sine 3x. Now what we're going to do, we're going to expand the brackets out. So we're going to have, now this is equal to 13 sine 3x. So now what we're going to do is expand the brackets out. So we're going to say, I'm going to write each one in a separate line so it's easy to see. So that's going to be minus 9c cos 3x minus 9d sine 3x. Now minus 5 times minus 3 is plus 15 c sine 3x. Then we get minus 15 d cos 3x, and then we get plus 6c cos 3x plus 6d sine 3x. Now all of this is equal to 13 sine 3x. So now we're going to simplify this down. So we're going to get minus 9c cos 3x plus 6c cos 3x is minus 3c cos 3x, and then minus 9d sine 3x plus 6d sine 3x will give me minus 3d sine 3x minus 15d cos 3x. Now all of that is equal to 13 sine 3x on the right hand side. So what we're going to do is we're going to get all the cos 3x terms together, so we can say that minus 3c minus 15d cos 3x, and then we're going to get all the sine 3x terms together, which is 15c minus 3d sine 3x. Now that's going to be equal to 13 sine 3x. Now the reason why I've done this is it makes the equating of the coefficients easier. So now I'm going to say equating the coefficients of sine 3x. So equating the coefficients of sine 3x. Now that's going to give me 15c minus 3d. 15c minus 3d is equal to 13, because that's the coefficient of sine 3x on the other side. And now we're going to equate the coefficients of cos 3x. So equating the coefficients of cos 3x. Now that's going to be minus 3c minus 15d. Now there isn't a cos 3x on the other side, so that's going to be equal to 0, which is my second equation. So I'm going to write the first equation underneath this, so we get 15c minus 3d is equal to 13, which is equation 1. So I'm going to times equation 1 by 5, so that I get a minus 15d for consistency. So times this by 5, and we end up with the following. We get 75c minus 15d equals 65, which is equation number 3. And then I'm going to write equation number 2 underneath this, so we get minus 3c minus 15d equals to 0. It's equation number 2. So we have the same signs because we've got 15d and 15d, so we can minus both equations. Equation 3 minus equation 2 to solve this simultaneous equation. So we get 78c, the 15d's will cancel out, so, or as in both minus 15d's will cancel out. So we get c is 65 over 78, and c would be, you can simplify that fraction down, to 5 over 6. Now we notice that we've got minus 3c minus 15d equals 0. Let's write that down. So minus 3c minus 15d equals to 0. And we can solve for d, so we can say minus 3 times 5 over 6 minus 15d is equal to 0. So we can say minus 15 over 6 minus 15d is equal to 0. Minus 15 over 6 equals 15d. Therefore, d is minus 1 over 6. Now, in the form of our particular integral, don't forget we've got that the particular integral is in the form y equals c cos 3x plus d sine 3x. So we said that we worked out c to be 5 over 6, so it's 5 over 6 cos 3x. And d is minus 1 over 6 and minus 1 over 6 sine 3x. So we can now say that our general solution is y is the complementary function plus pi. So in our case, it's going to be y equals a times e to the 3x plus b times e to the 2x plus a particular integral, which is plus 5 over 6 cos 3x minus 1 over 6 sine 3x. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we're going to solve the auxiliary equation. So we get m squared plus 2m plus 1 equals to 0. So we can say that's m plus 1. M plus 1 equals 0. So we actually get a repeated root, so m equals to minus 1 or m equals to minus 1. Don't forget, in previous videos I've explained these complementary functions, that when you got repeated roots it will look like this. So we get y is equal to a plus bx times e to the power minus 1x. So don't forget that our particular integral will take this form because we've got something in the form of k cos 2x. So we're going to say that assume particular integral take the form of c cos 2x plus d sine 2x. So let's differentiate this. So dy by dx will be minus 2c sine 2x plus 2d cos 2x. Find dy by dx squared. So I get minus 4c cos 2x plus, that should be a minus here, minus 4d sine 2x. So now that we've got that, we can substitute this into our differential equation. So we have dy by dx squared. So as what we did in the previous example, we're going to write it on the separate lines. So it's minus 4c cos 2x minus 4d sine 2x. Then we have plus 2 times dy by dx, so plus 2 times what we got for dy by dx. So let's write that here. So it's minus 2c sine 2x plus 2d cos 2x and then we just have plus y, which is the particular integral. So it's plus c cos 2x plus d sine 2x. Now all of that is equal to 25 cos 2x. So as before, we're going to expand and simplify. So we do it one line by line. So minus 4c cos 2x minus 4d sine 2x. So just for consistency, in the previous example, I'm going to use pink for this line. So it's minus 4c sine 2x plus 4d cos 2x, and then I'm going to write this in orange, so it's plus c cos 2x plus d sine 2x. So I will change that here as well, so for consistency. So we get c cos 2x plus d sine 2x. So it's consistent now. So all of this is equal to 25 cos 2x. Now we're going to simplify our expressions. So minus 4c cos 2x plus c cos 2x is minus 3c cos 2x. Minus 4d sine 2x plus d sine 2x is minus 3d sine 2x. And the pink terms remain. So we get minus 4c sine 2x plus 4d cos 2x. All of that is equal to 25 cos 2x. Now we're going to collect the like terms together. So we've got minus 3c plus 4d is the coefficient for cos 2x. And we're going to say plus, we've got minus 3d, or we could write it as minus 4c minus 3d sine 2x is equal to 25 cos 2x. So what we did last time, equating the coefficients of sine 2x, so equating the coefficients of sine 2x, we have the following: minus 3c of sine 2x, coefficient minus 4c, it's minus 4c minus 3d. Well, there isn't a coefficient of sine 2x, that's to be equal to 0. Equation 1. I'm going to do the same thing here, equating the coefficients of cosine 2x. So equating the coefficients of cos 2x. So that's going to be minus 3c plus 4d, and that's equal to 25, which is equation number 2. So I'm going to write down equation number 1 underneath it. So it's minus 4c minus 3d equals 0 to equation 1. So I'm going to times equation 2 by 3 times equation 1 by 4. So we end up with minus 9c plus 12d equals to 75. It's equation number 3. And let's do the same for second equation times by 4. So we get minus 16c minus 12d equals to 0. And that's equation number 4. So in simultaneous equations, we've got 12d and 12d, we've got different signs. So we can add both equations. It's equation 3 plus equation 4. So that's going to give me minus 9c minus 16c. When you add them together, it will give me minus 25c. The 12d will cancel out. So that's equal to 75. So c is equal to minus 3. So now we're going to solve for d. So we're going to say minus 16c minus 12d equals to 0. So minus 16 times minus 3 minus 12d equals 0. Minus 16 times minus 3 is positive 48. So we get positive 48 there. Minus 12d equals 0. So 12d equals 48. Therefore d is 4. So now what we can say is write down our particular integral. So y is c cos 2x plus d sine 2x. So our particular integral takes the form y equals, now we worked out c to be minus 3, so it's minus 3 cos 2x plus 4 sine 2x. So the general solution, our general solution is y equals the complementary function plus pi. So therefore y is going to be a plus bx e to the minus x, and for consistency writing the particular integral in pink, so we get minus 3 cos 2x plus 4 sine 2x is our general solution of the second order differential equation.